In this tutorial, we're going to look at the V-inlay technique. This is an alternative to making conventional pockets and inlays that uses a V-bit tool rather than the usual end mill or slot drill to cut these shapes out. Now, the reason this is significant is that by using a V-bit tool to create the inlays, we're not limited by the normal radius problem that you get from a rotating tool. So even in this artwork we've got here, which comes to sharp points and quite quick sharp corners here, you are able to keep this detail. So if we were trying to just pocket this shape out, firstly we'd have to find an end mill which would fit all the way along the length of this pocket, which would mean it would have to be extremely fine. And secondly, even if we could do that, we would find that we'd have radii on each of these corners, as the end mill can't get into the corner to properly clear the material. However, with the V-inlay technique, we can achieve this. So we can take this sort of artwork and produce an exactly matching dark wood inlay, as you can see in this example. So how's this done? Well, in essence, what we're going to do is cut two parts. We're going to cut the male inlay part from a dark wood material, and then the pocket out of the light material from a completely different piece of wood. But we're going to use the same artwork in each case, so that we end up with one example. The dark material is actually raised. So what we've done is use the V-bit toolpath, but we've carved away all of the material around outside of our artwork. And for the pocket, we've just V-bit carved all the material inside the artwork. So what you end up with is a matching male and female inlay and pocket, which we can now put together and glue. So we glue these two parts, rotate this one round on top of this one, and glue it into situ. And so that the male parts here are all now completely recessed into their matching pockets. And then, having done that, we can cut back the top surface again. So you're only left with the matching parts actually recessed into the pocket. So we would essentially either saw this top piece off or skim it back with our machine tools to leave a single surface at the end. But crucially, as I said at the beginning of this, we're now find that we've managed to maintain the sharp discontinuities in our original design, because the V-bit tool has allowed the inlay effectively to get shallower there, but maintain just with the tip of the tool the sharp profile of the original artwork. Okay, so let's go on now and look at how these two toolpaths were made. Okay, so we're going to start by creating a completely new file. So I click Create New File here. We're going to make this just 6 inches by 3.5 inches and a material thickness of about ½ an inch. I've set the Z0 to be at the top of our block here, and the datum for machining will be the bottom left hand corner, and we're going to work in inches, so that's all okay. So I click that and we've now got our working area. So the first thing we want to do is bring in our source artwork. So this is the bitmap that we're going to use as the basis of our design. So in the tutorials folder here I have the hummingbird JPEG. I can actually simply drag that from Windows Explorer directly into the software like so, and as soon as I do that and let go of it, it will be imported for me. So that's a quick way of importing artwork. You can of course also bring the artwork in by using the import button up here on the drawing tab, but it's very convenient to just drag things in like that. So now I've got if I just simply click on this once, it becomes selected. If I click on it twice, I get the usual things that you get in all the 2D drawing commands in the software, which is the ability now to transform or move around this drawing element. So I can drag it around, and I can also resize it with these white handles in the corner. So I can resize it dynamically like so and position it just by eye, or what I can do is use all of the standard transform tools here on the bitmap. So this one is to set the selected object size. So if I click that, I can actually put in a precise value. So in this case, what I'm going to do is ask for a width of exactly 4.5 inches, 4.5 inches. Because I've got the link XY selected here, the software automatically fills in the height for me to keep the image in proportion, so I can apply that change, and now I have my drawing and I know it's exactly 4.5 inches across. So I'll close that down. The next thing I want to do is center this exactly in my material that I created at the beginning. So there's various ways of doing this, but the quickest way, the shortcut key for this, rather than going to the Align Objects command on the drawing tab here, is to press F9. 9, so the function 9 key, and that moves the selected object to the center of my design. Okay, so that's the first thing I've got. So I now have a bitmap drawing. So this means that the picture is made up of lots of these little pixel elements. What we really need to do to create our toolpath is to generate a vector outline that matches this drawing, and to do that we use the tool on the drawing tab called bitmap trace, or trace bitmap here. When I select that with my bitmap highlighted, I get the options here to start to isolate areas of my image to which I'm going to fit my vectors. It's a black and white image, so I can use the black and white option here and only worry about finding the point I want along the sort of grey scales here. As I slide this, you can see that it's taking either more or less of the grey colours and including them in the area that we're going to fit to. Around about 80% looks good to me, so that's a nice area. Now I can choose how tightly to fit my vectors. So essentially this means that tight will try and pick up every single tiny undulation in the boundary. Often that is not what we want, because the bitmap has often got essentially noise in it, so it's got rough edges because of the nature of the scan or the way that the image has been captured, rather than because it really represents the true shape. So setting this value will allow you to either have a looser fit, in other words smoother curves going around this shape, or whether you want to pick up every single pixel change here. I've got it set to 80%, but if I click preview I can keep changing these options and click preview again until I see basically what I'm after. And in this case actually a loose fit's pretty good. It smooths things out quite nicely, and that's going to be a reasonable job, I think, for what we're after. The noise filter, if we had a picture which had lots of speckles, odd pixels here and there around the edges, which can be common if you've used a flatbed image scanner to get your image in, then the pixel filter asks it essentially to ignore 1 or 2 pixels up to 10 pixels here at the top. And then the bitmap fading allows me to adjust how bright my original bitmap appears while I'm doing the fitting. So obviously by fading it a lot I get to see more clearly the boundaries as they're being created with the preview button. So I've previewed it and I'm happy with the preview, so I need to keep the preview now. I'm happy with that one, so I click apply and then I can close, and I've still got my vectors boundaries here. Okay, so the next thing I want to do now is we've essentially finished with the bitmap. We're not going to be using that anymore now that we've created the more accurate machining boundaries in vector form. So I go across the layers tab here, click layers, and I can see that there is automatically an extra layer being created for me when I brought the bitmap in. So as soon as you import a bitmap image, the software will generate a layer for you by default called the bitmap layer, and that's quite convenient. We can just turn that off and the bitmap image which is on that layer is now hidden from view. So it's still there, we can bring it back whenever we like, but essentially we can hide it now for the rest of the process because we won't be needing it. Everything else we're doing is focused on layer 1, but because I know in a minute we're going to be creating more artwork, I'm going to rename this layer now so we can keep track of it, and we know that this is the artwork that I'm going to use to make the pocket. So I'll just call this layer pocket. And that will help later on with organising things. And that's all we need to do for the layers. Really, this is all the artwork preparation that's required. So the next thing we're going to do is move across now and look at the toolpaths. Because things generally do seem to be split often when you're doing designs between the design process and the toolpathing, although both bits of interface are always available if you use the little tabs on the side here, it's convenient when you know you're going to be focusing on toolpaths to switch to a toolpaths kind of layout, and we can do that automatically with the switch to toolpaths tab command here on the drawing tab. If I click that, it'll hide the drawing and the modeling tab, layers tab for me, and instead we'll focus on the toolpaths tab, which becomes pinned out. So as usual when you're machining, you need to just check your material setup is what you expect, and also it's worth pointing out at this point that if you're going to actually go along with this tutorial all the way through to machining the result, do make sure that the settings are appropriate for your machine tool. And similarly, when we start to create the toolpath strategies, make sure that the tooling is appropriate for the material that you're going to cut, the machine that you're using, and the tools that you in fact have. Okay, so the material setup's fine. I've got reasonable rapid Zs and home position there. So next thing we need to do is just go into our VCarve engraving toolpath here. So I'm going to open that toolpath strategy up. I'm going to select all of the vectors, which I can just do with box select there. And let's take a look at what we're going to cut here. So we can actually do our V-bit cutting straight away. We can limit the depth that we're going to cut to. We don't really want to keep carving all the way down to a sort of infinite depth here. So I'm going to just use 0.2 of an inch as my depth of cut. I'm using a fairly large 1¼ inch 90-degree tool here. If we have a look at the options in your V-bit tools, a 90 degrees is pretty good. Mine's a really big 90-degree tool, but that'll chunk away the material quite happily. Because it comes to a complete point, even with a large V-bit tool you can actually produce quite detailed work, because we just withdraw the tool so only the tip is used. Okay, so that's good. I'm going to also, because we've got some areas here where it would be quite inefficient to scratch away the material with my V-bit tool, I'm going to use a second end mill to do a lot of the area clearance if possible. So I've got a little 1/8 inch end mill here, and I've got this use flat area clearance tool where possible selected. Okay, and so if I have a look at that, it's the fairly conventional setup from the tool database defaults there. But what it means is when I come to calculate this, and let's call this one pocket, we will actually get little bits of area where we can using an end mill. So what we end up with here is two toolpaths, in fact. The V-bit, which you would expect obviously, but also this secondary one with brackets pocket after it, which is the end mill part of the process. And if we preview those, we can see the pocketing first, so it just gets a little bit of the material away with that, and then the V-bit. Now, using that pocketing will become more apparent when we do the mail part of this process, but having set that up once, we'll be able to reuse it, as you'll see in a second. Okay, so that's essentially it. That is the pocket part of our process done as quickly as that. So we can at this stage save our model off, and we could even export the first part of the toolpath and get that running while we start to work on the mail part of our process if we wanted to. Okay, so I've got these saved as pocket. We've got a layer which we've called pocket. The next thing we're going to do is go on to make the mail part of the design. Okay, so I've finished with my toolpathing for the moment. We're going to just change the design around a little bit and add some more geometry for the inlay mail part of the design. So I'm going to use the sort of reverse switch option here on the toolpath tab, which switches us back to focus on drawing operations and just unpins the toolpaths for us conveniently. And I'm going to go back up to the 2D view so that we can look at the artwork. Okay, so the first thing I want to do is I'm going to make a copy of this artwork but move it to our new layer. So I'm going to go to my layers tab here, add a new layer which we're going to call the inlay. And what I want to do is take a copy of these existing vectors and move them onto, so I can copy to my new inlay layer. So I've selected them and now I'm copying them to the inlay layer, and you can see a little bit there that we've now got two lots of overlapping vectors, and when I uncheck pocket we just see the selection in the inlay. So I've hidden now the bitmap and the pocket vectors, and we're just looking at a copy of the original vectors, which is now called on the inlay layer. And I'm going back to my drawing tab, and what I'm going to do is have to mirror it, because if you imagine, one of the things we're going to do when we roll over the top part of our design to glue it into the female pocket we've created, it needs to be a mirror image, because essentially it will be the bottom surface of the male inlay part that will have to mesh with the top surface of the female part, so effectively they're a mirror image of one another. So that's the first thing we're going to do. So with my inlay layer selected here, I'm going to go to the mirror tools. I'm going to flip about the job center, so we're going to keep everything centered around the middle, and flip horizontally. Okay, and now it's more easy to see with the layers what we've done here. So we've got two copies which are mirror images of one another. If I just flick on and off the pocket layer, make sure we focus on the inlay layer so it's visible and it's also bold. That means that's the one we're working on. The next thing I need to do is what we'd like, of course, with the pocket we machined away the inside of these vectors. For the male inlay we want to machine away everything except the area inside these vectors. And the way we do that is very simple really. We just draw a box larger than our material area here, and now when we select both the box and the internal vectors, the area that will effectively be machined will be everywhere between the outside box boundary and our vectors on the middle there. So that's what we need to do. So having drawn a box, we can now go back and start thinking about the male inlay part of the toolpath. Now we're going to focus on the Mail Inlay toolpath. I'm going to use the same button again to switch the toolpath tab, so that's a convenient way of setting up our view for toolpathing. But what I'm going to do, rather than go through the process of creating my VBit toolpath precisely again, I'm actually going to be using all the same tool geometry here. I'm just going to modify a couple of settings. So a handy way of doing that is to actually duplicate the existing toolpath. It's slightly complicated by the fact that the existing toolpath created two actual end toolpaths in our list, one for the VBit and one for the NMill. But as long as we use these and we're happy with the fact that when I click duplicate I get two toolpaths back, there's no problem with that. Okay, so it's duplicated both bits of that toolpath that we created. And now I can double click to go into the toolpath and we can modify some of the settings. So for starters, this is going to be the inlay. Okay, and what we're going to do now, the previous toolpath took us down to a depth of 0.2 inches. Now what we're going to do for the mail is split that 0.2 to be a start depth of 0.1 and a flat depth of 0.1. So effectively we're going to come down to make a little shoulder here and then machine our VBit depth down to the same total depth as the female pocket. So the resulting maximum depth we're going to achieve will still be 0.2, but we're going to machine away a little bit at the top here to allow the mail inlay to fit right inside the pocket that we've created. So effectively I've split the values there, 0.1 and 0.1, but everything else stays the same. We've got the same VBit tool, the same NMill, same other parameters. I've changed the name here. The final thing I need to do is select all of the vectors that we created. So that's the flipped, mirrored version of the original artwork plus the boundary vector, so that we machine away the area between the two rather than inside our artwork, and click calculate. And immediately it takes us to the preview toolpaths block again, and it's initially a little bit confusing because we've got the simulation of the previous pocket toolpath still visible there, but that's okay. We can reset the preview and now we can see our toolpaths more clearly. They're both visible by default here, so we can just preview the visible toolpaths to see the mail part. And as you can see, what we've done is use that NMill to machine away the vast bulk of the material, and we've now produced the VBit cut as well outside of all of our artwork. So we've now got a matching inlay that will fit inside the pocket that we'd created first. And both bits of our both toolpaths are now in the same file. Obviously we'd need to output these pairs of toolpaths separately because we're going to cut different material with each. But essentially that's the process, and it can lead to some really spectacular results. So I hope you enjoyed this tutorial.